Hey minds, bio and digital. Do you sometimes feel confused about the AI hype? Is it just a nice little upgrade like the smartphone or the internet or the wheel? Or is it gonna change our lives radically? I'm on a quest to find that out, and to me there's one very overlooked aspect of AI, and that is the intelligence explosion, or as I call it, Foom. Is this AI hype cycle going to end in a glorious Foom where we live forever in harmony with nature? Or is it just going to be an uneventful flop where a bunch of people walk away with a bunch of money and we will end up with nothing more than some chatbots? If you make it to the end of the video, I may even drop some estimates as to when I think that Foom could occur and with what probability. And by the way, is Foom a good thing? What's at the other end of it? Is it going to be a beautiful utopia or is it going to be hell? Alright, first things first. What is the intelligence explosion or Foom? It is the idea that we have a rate of AI progress, and that progress could accelerate tremendously. From a very fast speeding car to a rocket. It's like a whole different paradigm. But let's give Foom justice and go into the details of what I actually call Foom. I have 3 definitions for this. Here's the light definition. We have a bicycle and we are headed 20 kilometers an hour towards an unknown hill. And we upgrade to an electric bike. That is AI. AI is helping us already today to do AI research. But there will come a point where the electric bike and we will do the same amount of work. So the first light definition of Foom is AI doing half of AI research. My second definition of Foom, a 2-fold increase in algorithmic progress compared to the 2020 to 2024 baseline. For a given amount of GPUs, how much computing power, how much smarts are we getting? So algorithmic progress is like the fuel efficiency of our car. How many kilometers can we cover with 1 liter of gasoline? Foom will definitely start where humans are only adding noise, meaning that AI is better at doing AI research than AIs together with humans. So are you going to lose your job? Are we all going to die? And how much do we have left? Or, on the flip side, are we going to live forever and cure cancer and terraform Mars by 2040? Let the arguments roll. And please let me know if I missed any. So here are 12 arguments for Foom. Number 1, recursive self-improvement. Self-improvement means that AI will understand its own code and will be able to improve the very code that it runs. The recursive part means that as soon as AI has made itself better, it will become better at making itself better too. So each iteration of AI making itself better will be shorter and shorter, or the improvement will be bigger and bigger. So AI will improve itself again and again and again, and within months we could end up with something that we cannot even comprehend, something like a god. If recursive self-improvement is achieved, then the hard definition of Foom is in full swing. This is an exponential type improvement, that's why I gave it a weight of 8. I only gave it a probability of 6 to be cautious because LLMs, as they stand today, they cannot directly improve themselves. It potentially takes a lot of time and research to come out with the next iteration. So recursive self-improvement is definitely an exponential process, and it takes place in the 3rd phase of Foom, where it will lead us to the moon. Let me introduce you to this chart that GPT-01 preview helped me make to illustrate Foom. The AI progress is denominated in intelligence on the y-axis, and on the x-axis we have time denominated in months. Phase 1 is just AI progress. It's a straight line. The border between phase 1 and phase 2 is what I call a tipping point, where AI progress becomes super linear. It goes faster, it starts to accelerate. The border between phase 2 and phase 3 is what I call liftoff. And it will start with some sort of recursive self-improvement. In phase 3, within months or weeks, we could reach super intelligence. Argument number 2, productivity increase in AI research. Now, this is the light definition of the start of Foom. It basically means that AI is helping us create better AI faster. It's like an electric bike where we still have to push hard, but the electric bike is already helping us go faster. And the question is, what's the point where it's going to significantly increase our speed? AI researchers today use a bunch of AI tools to get their work done, but I'm not sure if it's improving their work 2x just yet, at least not today. We may be very close though. I did give it a high probability because AI researchers today are already using advanced AI to make their job faster. Productivity increase in AI research plays out in the second phase of Foom, where AI capabilities accelerate exponentially already, but with a lesser slope than in phase 3. Number 3, increase in computing power. Easy one to understand. It's the more compute you add, the better our AIs are getting. It's like adding more horsepower to your car, it just goes faster. Increase in computing power along something like Moore's Law has been one of the major drivers of AI improvement so far, and it will continue to be the case. That's why I gave it a high probability. Compute increase has been lifting and pushing AI progress from the background, and it corresponds to a higher slope on our Foom curve. Number 4, algorithmic progress. This is like the opposite of compute because you need less and less compute to achieve the same. It's like hitting that subscribe button, which allows you to get deeper insight way faster into the intelligence explosion. Basically, we need less and less GPUs to achieve the same AI performance every year. Surprisingly, the effect of algorithmic progress is the same as that of compute increase. It just gives our intelligence explosion curve a higher slope. Algorithmic progress is like the fuel efficiency of your car. You need less and less fuel to cover the same distance every year. Algorithmic progress has been steady in the past 5 years, adding a silent lift, a silent push to AI development in the background. I was very conservative and gave it a probability of 6 because maybe all the low-hanging fruits have already been picked and there's not so much more algorithmic progress to be had. Number 5, compute overhangs. This is like a nitro booster which only works at speeds above 200 kilometers an hour. We have a ton of compute today, but we use it to generate pictures and answer questions. So we are running millions of these instances in parallel today. But imagine if you could turn those Midjourneys and ChatGPTs into advanced math geniuses and computer gurus. There's a force in numbers, and millions of AI researchers could revolutionize the field of AI, basically turning this chart into a vertical one overnight. So probability is high because we know that this exists. We know that there are millions of instances run today. With the weight, I was a little too conservative. I should have given it a 6 because if we hit this, we're going to the moon. It's like the DeLorean that accelerates relentlessly, and as soon as it reaches 88 miles per hour, it goes Foom back to the future. The curve, it corresponds to the start of phase 3, and it defines the steepness of phase 3, which could be very steep. Number 6, reinforcement learning. Is AI figuring out how to become its own best teacher? What are the points to improve and how? So this is an AI improving itself, but it's maybe not recursive because you can increase the students' capabilities, but it's not clear that the teacher would also get better at it at the same time. Reinforcement learning will manifest in a steeper slope of the curve in the second and the third phase of Foom. Number 7, scaling laws. This is no law of physics. These models, they just want to learn. You give them more data and you shove them more compute, they will get predictably better. At least it has been the case so far. Now, this is no fundamental law of physics, hence the low probability. But large language models like ChatGPT and Gemini have been getting better. It's like predicting that if you upgrade your car with a bigger engine, it's going to go faster. Pretty straightforward. Number 8, growing context. It's AI's capability to understand more at the same time, to think about more things simultaneously. It's like the size of AI's working memory, and it's expanding rapidly. Growing context windows could allow recursive self-improvement to kickstart by allowing AIs to consider many different things about themselves while trying to improve themselves. Growing the context is akin to understanding one chapter of a machine learning book to understanding several volumes. Growing context will define how fast the third phase of Foom will start. And even though your average ChatGPT or Midjourney user will not find this useful at all, it will for sure make a difference at the frontier. Number 9. New machine learning paradigms. Now, this is the holy grail of machine learning. LLMs are the leading paradigm today, producing word after word relentlessly, but we know that they are extremely inefficient. They are way more inefficient than our own brains. So that lets us think that there is a different way of doing machine learning that's way more efficient. If we could unlock a paradigm that could learn 1,000 times faster, then boom, overnight, we could get to the end of the Foom chart. It's a car that we upgrade every year, and it gets faster and more fuel efficient every year, and people are designing wings for it to be able to fly. Maybe it's enough to strap some wings on a muscle car to go to the moon. But people are working today in labs to design literal rockets. And if someone finds that formula, that secret sauce, that blueprint for the rocket, boom! By looking for new machine learning paradigms, we are looking for an entirely different curve, whose shape could be. Number 10, unhubbling. People call it different names like Q-star, strawberry, mixture of experts, tree of thought, system 2 thinking. Basically, it's the idea that you think before you speak. It works for humans, it also works for LLMs. Or instead of talking to yourself, you summon 100 experts who each bring their own unique perspective to a problem, which no one could solve on their own. Unhubbling lives from those compute overhangs, which already today are contributing to our AI systems punching way above their weight. Our prophet Leopold has an extensive and comprehensible list of all these different unhubblings, and these all contribute to lift and elevate the entire intelligence explosion curve a little in the background, which all make the entire curve a little steeper, comparable to increasing compute and algorithmic progress. Number 11, progress made in benchmarks. All the different benchmarks that you look at today point towards AI getting better and better. We all know that. But at what rate? How good are they getting? And benchmarks are all confirming that the rate of progress in AI is very, very steep today. So this is defining the initial slope of Foom. We cannot know if progress measured in benchmarks will improve, but just like the scaling laws, this is something that people are confident is going to continue on in the future. I only gave it a probability of 5. I should have given it a 6 or 7. Number 12, new models keep surprising. Every time a new model comes out, it punches above its weight. It surprises people with new emergent capabilities. On our Foom curve, this corresponds to like discrete steps where instead of some little progress, there are always like jumps every time a new model comes out. So, end of the first round, all the scores for Foom add up to about 300. So that's our score for Foom. But what about the arguments against Foom? What about flop? What if all we will end up with is very good chatbots and very, very well done AI movies and only 50% of all labor automatized? Maybe we will contain and control our AIs forever. Let's dig in. Reason for flop number 1, fundamental limits to intelligence. Indeed, maybe there is a hard limit. Maybe there's a level that we cannot surpass. Maybe there's a hard limit to how smart any system can get. Like a speed of light, but for intelligence. We have absolutely no indication that such a limit should or could exist, hence the low probability, but hey, you never know. Imagine a chess-playing AI that figures out all the possible steps in a game. It's unbeatable by definition, so that you cannot make a better chess-playing game than the chess-playing AI that already considers all the possible moves. However, life is a bit more complicated than a chess game. Reason number 2, breakdown of scaling laws. Bigger models may not continue to be qualitatively better. You give new AI models more data and more compute, and they just don't become as much better as you expected. It's like your car that you upgrade with a bigger engine that's an extra 200 horsepower, and you predict that it will be 50 kilometers an hour faster. but it turns out on the field that it's only 20 kilometers an hour faster. Maybe you forgot to account for polynomially more air resistance. A breakdown of scaling laws is possible. I had to give it a conservative probability of 4. Number 3. Hardware setbacks. Global conflicts could disrupt AI development. This is large-scale war, disruption of supply chains. An even scarier version of this is destruction of currently installed computing power. If TSMC and ASML blow up, then we will not be able to produce better, faster, and cheaper chips. It's like you want to upgrade your car, but the factory that was making the parts is not online. Hardware setbacks could flop out the Foom chart by giving it like a lesser slope. Number 4, the data wall. So newer models eat more data, not just more compute to grow. And they need a special blend of compute to data. Namely, they need something like 1.7 tokens per parameter to grow efficiently. So if compute or effective compute keeps increasing relentlessly, but we do not find new sources of data, and in fact, we've already exhausted the entire internet plus all books, well, then maybe we'll just flop out. So I gave this one a high probability of 8 because we know that we are hitting that data wall. We have already used something like 20 to 30 trillion tokens to train the latest models. But why the low weight of only 2 on this argument? Well, that's because experts agree that the way forward is a different type of data, a data we do not currently have. It's synthetic data. The data that we feed our models today is low-quality, pathetic Facebook posts and Reddit conspiracies. There must be a better quality of data, and crucially, this new synthetic data could be produced at scale by AI itself. This new type of data, the synthetic data, should be of the sort that resembles more of an inner monologue, or maybe a conversation between 10 experts debating a subject, something that incites more reasoning. And the synthetic data ties us back to reinforcement learning, because if we are allowing models today to teach the models of tomorrow by generating that synthetic data, that's something like the curriculum for the next generation of AI models. One way that this is currently happening already that we know of is GPT-01, generating a shit ton of very high quality reasoning data, where it's going through logical steps, where it's analyzing how it's thinking. GPT-01 can simulate virtual debates between different experts, giving the next generation, Orion, a better chance to know reasoning from the get-go. In short, the data wall is here, but we don't need to jump over it. We can just go around it following the path of synthetic data. Newer models cost more. Indeed, every time a new model comes out, it requires more compute and more energy and more money to run. Maybe this increase in resource requirements will become unsustainable. In fact, we know today that better models cost more to run, hence the high probability. But why the low weight? That's because compute is getting exponentially cheaper, in fact. And also, you have to consider the value of the output. If the value of the answers justify the cost, then there will be a market for it. For example, high quality legal and financial advice, science and technology research, expertise in cybersecurity and military edge. This could all be worth way more than the little increase in price that we're getting with each new model. Reason number 6. AI labs don't want Foom. OpenAI and Anthropic know that they can only generate a profit as long as they own their models, as long as they use their AIs as slaves that generate profit for them. Frontier AI labs should also have a notion that creating an AGI could potentially lead to a rogue AI or an AI takeover, and they should consider that in the event of that happening, if it turns out bad, it will end the world and them with it. So this is an argument for self-preservation. If you know that you're playing with fire, then maybe you should be cautious about it. So this is just self-preservation. It's making sure that they don't create either God or Satan, because then they will lose control. That's why these frontier AI labs do alignment. They hope that they can control whatever comes out of the next training run indefinitely. it is a high probability argument because it is known that there's a chance of doom, right? I give it a ridiculously low weight because this is an arms race. The hands of the leading AI labs are tied. They have to be first. There's no second place in the race for AGI. This is what Ilya saw. This is the inevitability of Foom. If they don't let the genie out of the lamp, then maybe Buzzmag. So even if you know that you're playing with fire, your hands are tied, you're kind of forced to be the one who lets the genie out of the bottle. These frontier AI labs are aware that if they don't let the genie out of the lamp, maybe the Chinese or the Russians will. But this brings us to a whole different subject, which I'll cover another day. In short, the weight is one because their hands are tied by economic and geopolitical reasons. So, these were the 6 reasons for flop. Let me know if I missed any. And their score adds up to 77. So, you made it to the end of the fight. Is it Foom or is it flop? The jury is still out. To me, we have 3 times as many arguments for Foom than for flop. This to me translates to the subjective 90% chance of Foom, which to me pretty much means there's a 90%-ish chance that we will create an AI god or an AI Satan. So before I let you go, I'll just flesh out 2 things real quick, and these are going to be spoilers. One is about timelines. If Foom indeed happens, it's going to happen soon or later. And also, if it does happen, what are our odds? Are we all gonna die or are we gonna end up in paradise? Do we have an AI God or an AI Satan who will come to Earth? Or, as I like to call them, Moksha or Ares. Warning, this is a total spoiler of 2 of my upcoming videos. So you get 5 seconds to close this video, then I'll spill it. You can use these 5 seconds to drop a like. 1, 2, 3, 4, 5. Here we go. Here are my reasons for shorter and longer timelines, and it comes out to something like 3 to 1 on the side of pro, on the side of shorter timelines. That skews my prediction for Foom to something like 15 months from now, around like December 2025. So December 2025 is my median prediction. That means this is a cumulative probability of around 50% that Foom will happen by then. So this is how I visualize Foom. Basically, we have a probability distribution. The orange curve is the monthly probability of Foom happening in that particular month, and the blue curve, cumulative probability, right? So it tops out at 90% because I think there's a 90%-ish chance of Foom ever happening, but when it will happen follows a probability distribution. I just don't know. But my best answer to when Foom is to give you my median estimate for about January 2026. But it could very well happen by 2028, just with a lower probability, you know. By the way, GPT-01 has helped me make this curve, and you can find this curve on my website, so link in the description. And you can plug in your own numbers, you can play around with the chart, and you can see if you're optimistic or pessimistic. I also made this Google Sheet public, so you can plug in your own numbers, and you can add some arguments, pro and con, and shorter and longer timelines. I am doing this to invite discussion. Nobody seems to be taking Foom seriously on the internet. I have not seen anyone who has done this sort of rational assessment of Foom or flop. Yet the implications are tremendous. If God will literally arrive in 2 years, then this is the biggest single thing that ever happened to humanity. It needs more attention. I'm just a guy who was interested in AI tech, and the more I was delving into this, the clearer it got for me that there's going to be this takeoff, this Foom. And I'm looking for people to disprove me, because I found myself predicting the coming of an AI god. And I'm desperately looking for arguments from people who can demonstrate that I'm crazy. Because if I'm not crazy, we are in for another spoiler. 5, 4, 3, 2, 1. 75% utopia and 25% doom. Stay tuned to find out how I came up with those numbers.